So review as it is video support for calculus, um, applications of derivatives. So before we delve into the applications of derivatives, because one of the applications really is for us to find maximums and minimums. We call this extremums of a particular function. So before that, we discuss first how we notify intervals. Intervals really are x values, a range of x values. For example, there are two cases for intervals. We have the open intervals. For open intervals, we notify it like this. For example, I have a negative 5 and 5 interval. So that is x from negative 5 going to 5. It's like saying that is range of values from, let's say, that is going from uh, negative 5 and 5. Of course, you have your 0 here. Then you have 1, 2, 3, 4, and then you have negative 5. And then also 1, 2, 3, 4, and then 5. That is negative 5 to 5. But if it is an open interval, you don't include negative 5 and 5. So meaning, in drawing, usually it is drawn like this. May buhok ka dida, and then you extend may buhok ka didi. Meaning that hole there, meaning it doesn't include the negative 5 and 5. So that is an open interval. So in mathematics, if that is x values, we also say negative 5 in terms of what they call this inequalities. Negative 5 is great x, that x values is x greater than negative 5 but is smaller than a positive 5. As you can see, you have the greater than, meaning it doesn't include the number negative 5 and 5 as well. So that is an open interval. In contrast with a closed interval, you have a notation like this. So that would be if you have an example of negative 5 to a positive 5. So it means that your range of values, or your, if that is an interval, so that should be a straight line from 5 to a positive 5. Of course, without a hole onto it. So everything is shaded. So meaning it includes 5. So the notation for this in inequalities, we say x is greater than or equal to negative 5, and then take note of that equality, and then which is lesser than or equal to 5. So this guy is translated as this, while this guy is translated as this. So take note the difference of the equality. So meaning this one will have values ranging from a negative 4.99999, as many nines as you can have, and then probably 999, almost 5. It just means that almost negative 5. And also for this particular guy, you have values up to 4.999999, as many 9 as you can make before making 5. So that's what it means. While this one, you can include negative 5, of course, as the last option. So again, this guy is represented as this, while this guy, those guys are represented as this. Okay, so this is a open interval. I'm just also reviewing before we delve into the topic, and this is what we call a closed interval. Okay, so I guess that's the first topic that we have to review. Of course, we because I'll be making short video clips, as much as I should not go beyond 15 minutes. So anyway, I'll make a pause 4 minutes. So if you have problems like this, find the open intervals where the functions graph as follows are as increasing or decreasing. So maybe we can just copy this one. Let's just copy. I'll try to copy now. Try to open my then and then I'll try to insert. So I'll try to copy this first so that I can answer. So your problem is you have to find an open interval. So again, the problem is about open intervals where the functions graph as follows are increasing and be decreasing. So as you can see, you have an increasing, hello? So you have an increasing values from, as you can see here, from a particular infinity because it goes that arrow, meaning it continues into infinity, and even also this arrow. So meaning from negative infinity, if that is an open interval, if we're just asked for open intervals, that should be negative infinity up to that value positive 1. So that should be an open interval. So that should be an open interval of, so this one is a positive 1. So therefore we would have an open interval of negative infinity up to that value, which is a positive 1. So if it is positive, I should not be making any positive already, except for if you're talking about the positive infinity. So that is an open interval for a decreasing function. So this is letter B. If you're trying to answer this question, so this is letter B. A decreasing interval from negative infinity. So this is negative infinity. Okay, up to here. So the lowest point, negative infinity to 1. While an increasing part, which is A, so for letter A, the answer would be a 1, an open interval from 1 up to a positive infinity. So since it's an infinity, you have to put the positive. So it looks like that. If that is an open interval. I guess I was answering this with close interval during my lecture. So um, anyway, I inputted a close interval for my answers. But anyway, since the problem is only asking for open intervals, so this should be the answer. An open interval from 1 to positive infinity for your increasing function. So this is increasing. And negative infinity to 1, which is your decreasing. As you can see, the point here is just we can identify that 1 really is a critical point, meaning it changes from decreasing to increasing. Okay, so that is number 1. How about letter number 2? So this is some kind of a reverse. So you have from negative infinity to a positive 4. So you have a negative infinity to a positive 4. So an open interval from negative infinity to positive 4 is increasing. So this one is letter A. This increases, okay? And then for letter B, the decreasing function from your 4 to a positive infinity. Of course, it goes beyond going down. So your x-axis, again, these are x values, huh? So that's negative infinity. So you have a negative infinity here and a positive infinity here. So meaning from 4 to positive infinity, your graph is already decreasing. So that's how you answer this type of problems. Maybe more problems. Anyway,